We come in contact with acids all the time. We eat them, we drink them, we even have them inside our bodies. And we make use of acids in the laboratory. These are some of the most common acids: hydrochloric acid, sulfuric acid, and nitric acid. You'll find it very useful to memorize these names and formulae. You can also find lots of alkalis around you. In your house, for example, you might find sodium bicarbonate, which is used for cooking or to help relieve indigestion, milk of magnesia, which is given to help an upset stomach, and ammonia, which can be used as oven cleaner and for general household cleaning. And in the laboratory, you can find the alkalis sodium hydroxide, potassium hydroxide, and ammonia. Again, try to learn these names and formulae. Acids are made when non-metal oxides dissolve in water. For example, sulfur dioxide reacts with water to give sulfurous acid. Sulfur dioxide is one of the gases which contribute to acid rain. Alkalis are made when a soluble metal oxide or hydroxide dissolves in water. For example, sodium oxide reacts with water to give sodium hydroxide. We can tell if a solution is acid or alkaline by testing the pH using universal indicator or pH paper. In industry, a pH meter is used.
This is a pH meter. It's a fairly standard piece of laboratory equipment, but it's one that's invaluable for the teaching of one of the key concepts in chemistry. pH crops up all over the place in environmental chemistry, and it's equipment like this, with the electrode that does the measuring, that's used routinely in process chemistry in industry. If you want to teach chemistry, you really do need one of these.
pH is a continuously numbered scale which ranges from 1 to 14. Acids have a pH of less than 7, which shows up red or shades of red with indicator or paper. Alkalis have a pH greater than 7, which shows up blue or shades of blue with indicator or paper. Substances like water, which are neither acid nor alkali, have a pH of 7 and are said to be neutral. This shows us light green with indicator or paper.
We've got some ordinary cola here, and if I dip this in, what you can see there?
Ah, now that's gone quite pinkish, sort of orangey colour.
Here I've got a table that shows the range that you can go through, and it goes through from red, which is acid, through to blue.
So that must be an acid?
That is right, that's an acid. So an acid will turn towards the orange or the red colour. And here I've got some ordinary household bleach, and then if we test this again, what do you see there?
Wow, now that's very blue, greenish. So that's an alkaline.
Alkaline.
Right. So can we do some more testing?
We certainly can. I've got a nice one for you.
Okay.
Perhaps you'd like to just test your saliva. So I'll tell you what, if you'd like to put a little bit of saliva in there, then
right.
Let's see what we get now. There we are.
That's
now,
green.
You see there, that's very slightly green. What that shows is slightly alkaline.
Good match.
Yeah. Why don't have a bite of one of those oranges and get a nice bit of orange juice in your mouth?
Okay, tough job, but someone's got to do it. Very juicy.
Now, if you have another spit, if you don't mind, in there.
Excuse me. Okay.
Right, so how's that gone?
Slightly orange.
Yes, that's right. So that's on the acid side, okay? And when the citric acid gets in your mouth, it turns it to acid.
Right.
Now, there are other acids that hang around in your mouth, and although the saliva can neutralise these acids, some it can't, and that's why it's important to brush your teeth.
Here's a summary of the pH scale. You'll find this a helpful revision aid, so pause the tape and copy it down. pH is a measure of the hydrogen ion concentration in a solution. As an acid is diluted, the concentration of the hydrogen ions decreases. The solution becomes less acidic, and as a result, the pH rises towards 7. As an alkali is diluted, the concentration of the hydroxide ions decreases. The solution becomes less alkaline and the pH falls towards 7. In addition, at credit level, you should also know that pure water contains hydrogen ions and hydroxide ions, but in the same concentration. They balance the effects of each other, so the solution is neutral. Acidic solutions contain more hydrogen ions than pure water. Alkaline solutions contain more hydroxide ions than pure water. Here's an exercise. You're given 3 colourless solutions and told that one is acidic, one is alkaline, and the third is neutral. Describe an experiment you could do to prove which one was which. Write down the names and formulae for 3 common laboratory acids. To work out which solution was which, you should test the pH using universal indicator or pH paper. The acidic solution would show red and have a pH of less than 7. The alkali solution would show blue with a pH of more than 7. And the neutral solution would have a pH of 7 and would turn the paper or solution light green. The most common laboratory acids are hydrochloric acid, formula HCl, sulfuric acid, H2SO4, and nitric acid, HNO3. If you've thought of any other acids, be sure to check with your school notes that you're correct. You'll need to know what happens when acids react with different substances. When an acid reacts, its acidity is reduced because the hydrogen ions which govern its pH are used in the reaction, which means its pH moves up towards 7. When acids react with alkalis, water and a salt are produced. The pH of the acid moves up towards 7 and the pH of the alkali moves down towards 7. In other words, they both move towards neutral. For example, hydrochloric acid reacts with sodium hydroxide to give water and sodium chloride.
This is a model of the stomach. And inside, there are lots of different chemicals, including, would you believe it, hydrochloric acid, which is a very strong acid with a pH of 2.
And that acid is there to aid digestion.
Now, if the acid builds up, you can start to feel unwell, a bit windy, you know the feeling. So, to calm the stomach, you have to neutralise the acid by adding an alkaline substance. Now, these indigestion tablets contain bicarbonate of soda, which is the same sort of alkaline you can use on bee stings. So, when the acid and alkaline react, you get a salt plus water. Now, the salt is harmless and the water is neutral, so it calms your stomach.
When acids react with carbonates, water, carbon dioxide and a salt are formed. For example, sulfuric acid reacts with calcium carbonate to give water, carbon dioxide and calcium sulfate. Any reaction of an acid which results in water being produced is called neutralisation. In every neutralisation reaction, hydrogen ions are removed from the solution as water. A substance which neutralises an acid is called a base. Soluble bases form alkalis. You should know which ions are reacting in a neutralisation reaction. Here are the formula equations for acids reacting with alkali and with carbonate. Metals react with acid, but hydrogen rather than water is formed, so this is not neutralisation. When metals react with acid, hydrogen gas and a salt are formed. Here are some examples. Hydrochloric acid plus magnesium gives hydrogen and magnesium chloride. Sulfuric acid plus zinc gives hydrogen and zinc sulfate. In both these reactions, 2 hydrogen ions plus 2 electrons gives H2, hydrogen gas. Test yourself on this section so far by completing the following equations. Hydrochloric acid plus potassium hydroxide gives water, and what else? Sulfuric acid plus magnesium carbonate gives magnesium sulfate plus what two other products? Nitric acid plus zinc gives zinc nitrate plus which other product? Write equations to show what happens to the hydrogen ions in each reaction. Hydrochloric acid plus potassium hydroxide gives water and potassium chloride. In this case, the hydrogen ion combines with the hydroxide ion to form water. Sulfuric acid plus magnesium carbonate gives water plus magnesium sulfate plus carbon dioxide. Here, the hydrogen ion combines with the carbonate to form carbon dioxide and water. Nitric acid plus zinc gives hydrogen plus zinc nitrate. Two hydrogen ions accept one electron each and become hydrogen gas. The burning of some fossil fuels produces acidic gases. For example, coal burned in power stations can produce sulfur dioxide. Petrol burned in a car engine can produce oxides of nitrogen. Because they are oxides of non-metals, they dissolve in the water in the atmosphere to produce acidic rainwater or acid rain. This causes pollution problems.
Coal is made of plant material and so it contains sulphur, some more than others. And when it's burned, that sulphur is released as sulphur dioxide, SO2, which dissolves in water and turns the rain superacid. With the industrialised world burning more and more coal every year, and with other sources of acid from petrol, oil and chemical processes, it's little wonder that things are going wrong in an increasingly dramatic way. Trees and whole forests have been and are being killed over very large areas. Hundreds of kilometres downwind from any major industrial input, lakes have lost all their fish. Because you see, as lake waters get more acid, poisonous minerals like aluminium, zinc and lead flood out into solution. So the problem is, can these lakes ever be put back into working order? In an attempt to find out, Loch Fleet on the west coast of Scotland was chosen for study. All its fish had died of too much acid back in 1970. Then, in 1986, powdered limestone was added to the catchment to neutralise the acid. Limestone is calcium carbonate, which slowly breaks down and neutralises the acidity in the rain, the soil and, one hopes, in the lakes. A massive job in this rough terrain, but on it went at 10 tonnes to the hectare. The liming worked, and with a bit of help, the fish came back to stay.
But it's not just wildlife that's affected. Acid rain also attacks metal structures like the Fourth Rail Bridge and buildings and statues made from stone containing carbonate. Rather than treat buildings and other structures to withstand the effects of acid rain, it's better to actually prevent the emission of the gases which cause it. Now answer these questions. Name the gases which are the main causes of acid rain and give their sources. Give 3 examples of damage caused by acid rain and 2 ways of reducing acid rain. The gases which are mainly responsible for acid rain are sulfur dioxide from burning coal in power stations and oxides of nitrogen from the burning of petrol in car engines. Damage caused by acid rain includes corrosion of metal structures, acid lochs and corrosion of buildings and statues. Acid rain can be reduced by the use of low sulfur coal and scrubbers in the chimneys of power stations and catalytic converters in cars.
This will probably seem like an obvious point, but please make sure that you read the question before you start to answer it. Don't just skim through it and think you know what it's actually asking you to do. Read it and read it carefully. Also have a look at the number of marks allocated to the question. That will give you some indication of the amount that you have to write in your answer.
Study for your prelims because it's like having a second chance at your exam. I got a total shock when I failed all my prelims, so it made me study really hard for my exams. Prelims are also good preparation for your exams, so the best thing is to do, take your prelims seriously and study hard.
My general piece of advice would be to make your study environment as ideal as possible. This can be achieved in many different ways, but having a hard back chair is important because otherwise you'll be too leisurely and just won't be in the mood to work. Also, a large table space is important as well because you need to have lots of space to spread out your notes properly.
I decided to take a Buddha that one of my best friends gave me into the exams with me, and I thought this was a really good idea because I thought it like a lucky mascot. But in the middle of the exam, my Buddha decided to fall off the table and clatter on the floor, and it happened 3 times. That was totally embarrassing. So I take a lucky mascot in, but didn't take an ornament.